Today's goal is to write and solve mixture problems. So this is the last of the classic examples of rational equations. Let's begin. If we're looking at mixture problems, you should know that the concentration of a mixture is the amount of solute over the volume of solution, which is less formally the amount of stuff you have mixed in out of the total volume of the solution that you're making. So let's contextualize that a little bit. What's the concentration of a solution composed of 3 liters of 5% acid? That means you have some pitcher. The volume is 3 liters, but only 5% of the stuff in here is acid, right? That would mean it's probably 95% water, like mixed in with all the acid. And you're mixing it with 2 liters. Okay, so we have a smaller amount over here. 2 liters of a 25% acid. Oh, interesting. So this guy is way more concentrated. We don't have as much of it, but it's got a lot more acid in it. So when it's saying concentration of a solution, it's saying like you're mixing some acid with some water, with some other acid and some other water, right? This is maybe a murkier solution. So how much acid do you have in your final solution? Well, let's see. The concentration would be the amount of acid you have in total divided by the total volume. This would be like saying if you could separate the acid from the non-acid bits, how much acid would you have in there? Well, if you have a total of 3 liters, right, and you're going to have some amount that's pure acid, it's 5% of the 3 liters. So that would be 0.05 times 3, which gives you 0.15 liters of just acid. That means you have everything else is just water, right? That would mean you have 2.85 liters of water, right? You don't actually have to separate these out because you're mixing these. You're adding them together in a giant bowl and stirring it up, right? But theoretically, if you could separate the acid and the water in this jar, you have a smaller volume to start with, but you have a higher concentration of acid, right? 25% of your 2 liters is acid. So that's like saying you have half a liter of acid in here. And the rest of it, which is incidental, you don't have to calculate this, you have 1.5 liters of water and half a liter of acid. Now, when you mix these all together, your new concentration is going to have 0.15 liters of acid from the first jar and another half a liter of acid from the second jar, and a total of, well, you've got 3 liters here and 2 liters here. So you're going to have a total of 5 liters. So that gives you 0.65 liters of acid inside 5 liters of liquid, which gives you a concentration of 0.13 or 13%. Does that make sense? Is that reasonable? Well, you took 25% and 5%, so your result should be somewhere in between because you have close to the same amount of volume for both. So 13% is between 5 and 25%, so sure, that makes sense. Okay, example 2, what's the concentration of a solution that's composed of 1 liter of 35% acid and half a liter of 3% acid? Does it seem reasonable? Okay, again, we're thinking about you have 1 liter of 35% acid. So that means you have 0.35 times 1 liters of acid, and then everything else is just water. This is a total of 1 liter in size. And the next thing you're mixing with it is half a liter of a 3% acid, so you don't have as much. You just have a total of half a liter. And you have some amount of acid. How much do you have? That would be 0.03, not 0.3, that's 30%. So 0.03 times half a liter of acid. So your new concentration, again, is the amount of acid you have in total divided by the total volume. So how much acid do you have? Well, you have 0.35 times 1 liter from the first guy and 0.03 times a half liter from the second guy over a total of 1.5 liters if you add up the total volume you're working with. And so this would be 0.35 plus 0.015 over 1.5, or you can just type this into your calculator. This gives you 1.5. Oops. This gives you 0.243, and the 3 is repeating. So this is 24.33% acid. Let's just check to see if that makes sense. Or you're dealing with 35% in a much smaller concentration. There's more of the 35%, so we're going to end up somewhere between these two numbers, but closer to the 35%. Oh yeah, that makes sense. Okay, if you have 10 liters of blueberry juice blend that is 60% juice, meaning 40% water, how many liters of pure blueberry juice need to be added in order to make a blend that's now 75% juice? Okay, well, our concentration, in this case of blueberry, would be the amount of blueberry juice divided by your total volume. This time, we don't know how many liters of pure blueberry juice. So let's call that X. This is the thing we don't know. The number of liters of pure blueberry juice. Okay, and you want to make a 75% juice blend. That's your desired concentration. So we'll put that on the left of the equation. Okay, you have 10 liters of 65% juice. So that means 60%. 60% of 10 liters is the amount of blueberry you have from the first concoction, plus you have X amount from this pure blueberry juice. So pure means 100% of it is juice. It doesn't have any water in there, it's just juice. So this would be 100% of X liters. Our total volume then, we're adding 10 liters of the first guy plus X liters of our pure juice. Well, this is just a rational equation which we can solve by getting a common denominator. So we have 0.75 equals, to make this easier, we can multiply these out, 6 plus X over 10 plus X. Well, and this is over 1, so our least common denominator will be 10 plus X. So we need to multiply here. We can multiply by distributing. So we get 7.5 plus 0.75x is 6 plus x. We drop the denominators because the denominators are the same. Therefore, the numerators must be the same. This turned into a linear equation. That's nice. We'll get the x's on one side. 7.5 equals 6 plus 0.25x. And we'll get everything else on one side. We can subtract the 6. You get 1.5 equals 0.25x. And so x is 6. Again, x is a variable we define. So let's go back to the original problem. How many liters of pure blueberry juice do you need? You need 6 liters of pure blueberry juice. Okay, we've got just a few examples left. If you have 10 liters of blueberry juice, that's 60% juice. How many liters of 25% blueberry juice need to be added in order to make a blend that's 40% juice? How many liters of 25% juice? That's the thing we don't know. We'll call it X. Again, my concentration is the amount of blueberry juice over the total volume. So we want a blend that's 40% juice. We have 10 liters of 60% juice. So 60% of 10 liters is the amount of blueberry juice you have there. How many liters of 25% juice. So we're going to add on 25% of X liters out of a total of 10 liters plus X liters. Again, you just have a rational equation. I'll leave it to you to solve by getting a common denominator. And then I want to look at this one final equation. Write a general equation that can be solved to find any amount A of 15% juice. This sounds like something I don't know. So an amount A of 15% juice to the 10 liters of 60% juice in order to create a mixture that is P%. Well, we're coming back to the same general equation each time. Concentration equals amount of blueberry juice over the total V, total volume. We want it to be P% juice. That means P over 100. Or you could write it as 0.0P. Right? So P over 100, P%. You're going to add 60% of 10 liters to 15% of A liters. And then your total volume, you've got 10 liters here plus A liters here. Let's actually solve this by dropping our label. So I've got P over 100 equals 6 plus 0.15A over 10 plus A. Again, get your least common denominator. I'll leave it to you to solve. Solve for A.